Hello, everyone, and welcome back to the stream. So last week I was working on, so I'd done up a little to-do list of some of the outstanding language features that I'll be developing. Again, the focus here is on getting the features working and correct and playing around with syntax and approaches and kind of researching the language rather than kind of having necessarily the cleanest code. Cleaning the code will kind of happen in a future podcast. It's our future stream is more focusing on getting things working and seeing what the approach is at first. And so what I did last week was did up a little to-do list of some of the outstanding features that I'm wanting to implement here and got started with kind of a mini project where I am converting the basically a public kind of bash script that is kind kind of going to serve as a guide for some of the next bit of exploration. I'll be basically converting this public script into this, you know, as converting it into an implementation using the Laurel programming language that I'm developing here, and seeing how I get, say, equivalent statements written in this language versus what it would be doing in Bash. So actually, what I'll do first, I forgot to open my little browser window, so I'll just run over to, is it get.docker.com? Yeah, so we have this here. So this will work as the source that I'll be working from, and I'll be converting it kind of trying to convert it relatively directly and have like for like. The piece I'm working on at the moment is so I got onto a part where in the bash source code what I'm wanting to do is, oh yeah, so it's basically at the very top here. We've handled retrieving a variable from the environment and handling the case where it isn't there by having a default value. Um, and I'm just at the point now where we've come across a kind of a bash idiom or shell, I suppose, rather, because this is actually all written in regular shell. And we have this syntax for stripping a prefix off a string. And I'm basically doing up the equivalent in the Laurel programming language. And the way I'll be approaching this, so in this language, there'll be, again, I have to come up with, say, a more, a clearer kind of wording around what's going on, but it's very similar to JavaScript prototypes, where the built-in values are the built-in types of the language, even though it's not statically typed, but there are types behind the scenes, and the types themselves will have certain functions associated with them. So, well, more like methods, because you call them on variables of those types. And so each type will have a collection of methods that you can call on them, but they'll actually be defined as defined in the language themselves. They'll be built in. I don't love the idea of having a language where it has kind of where the language can do things that the developer can't. So this will be unfortunately a special construct that, these will just be built in. You won't be able to define them yourselves, and the developer won't be able to define these themselves. Instead, the developer would have to use object kind of, define their own objects and define the methods in the objects. This is kind of actually kind of a workaround for the fact that user space or developer space methods and fields defined on objects we want to kind of distinguish the two. In JavaScript, you kind of have this conflation between, like, if you do dot length and you did it on a string, you're accessing the prototype generally, but then you could potentially overwrite that with your own local field values, stuff like that. So avoiding those kind of weird shadowing cases is kind of one of the reasons for just separating the two domains. And so you're going to have this immutable prototype that each value can access, which is based on its type. But the developer won't be able to modify those. They'll be defined by the language, which is a bit restrictive. But I think it's I suppose a valuable trade-off. So yeah, with all that said, where I am now is actually defining the first of these prototype methods, which is a method on strings, and it is going to be a strip prefix. So it'll take it can be called on a string. It'll take a string as an argument, the typical one, and it'll remove that from the start. If the prefix isn't there, then it'll return the string unmodified. I prefer the Rust approach, where you actually return none if there was no modification, and the variable in a sum type, if it was there, or a sum variant. But for this language, again, the emphasis is going to be on being more lightweight, maybe taking a few more shortcuts than I personally like when I'm writing kind of more robust software. But at the same time, that's a trade-off for the philosophy of the language almost. So with that all said, I'm going to basically just jump in. Where I had left it last week is I was looking at so I had implemented, I think, the basics of this, so the syntax, the initial call and things like that. Where I was though was trying to figure out how best to inject these this kind of these function definitions into the evaluation, because one thing I came up against recently was trying to add, I suppose, I don't actually have any good refactoring tools installed in this environment just yet, so I'm just using relatively raw Vim with syntax highlighting for Rust. It would be nice to be able to just add the dictionary mapping from value types to the map of functions that can act on those types, but I don't have that at the moment. One workaround that I might do in the short term is to actually just introduce, and again, it's not something I'm totally familiar with, but maybe introduce a global variable in Rust to basically just get the thing working more or less, because that's essentially going to be the functionality of these functions, is to just have this global set of functions that are methods that can be called on the different types. So we're not getting as much from the dependency injection, even though it is the clean way of doing things. But because of that, so I'll probably look at seeing, can I do the global variable approach for now, and then later I can refactor it into using proper dependency injection. Maybe even a better approach would be to define an evaluator type that all of these evaluation functions will be within, and then those built-in methods will be defined on the evaluator and can be accessed directly from where it needs to be accessed, because it doesn't need they won't be changing as they propagate through the call stack. Anyway, as usual, I've done a lot of talking, not much coding. So let's get stuck in. So first thing to do is to actually find out if what I'm thinking in terms of global variables is actually a runner. So let's see, Rust global variables. And let's see, heap allocation is allowed, and where it's performed at runtime. As long as there's thread local. Because the thing is, I am aware of for example, the fact that sometimes you can define a lifetime as static, which I suppose is what this is referring to, where you make the lifetime of an object the lifetime of the process of the program. Let's see, constant static section of the Rust book. So those seems, yeah, so those are still yeah, it can't be computed at runtime. Whereas the functions we'll be wanting to define. Hmm. Lazy static. Let's see. Like the approach that I know actually works is the clean injection approach. I'm just wary of spending a lot of time adding those new parameters to all the functions that require them. But maybe have I another approach? So global variables don't seem to be a runner. I suppose no. Yeah, realistically, Rust isn't going to want to let me do this. So in that case, my best approach probably is what? In fact, so I did get started on the bones of an implementation of something last week, didn't I? Where I was kind of piggybacking on the existing definition for kind of imports. And where did the standard come from? So standard was a hash map of strings to values. So basically just the standard library. So 965. 974. And 968. So what I had started doing last week was defining a new. So these are kind of built-in modules, so to speak, and I was kind of piggybacking off that system so that I didn't have to define a separate set of them. And I wonder, will I potentially just reuse that, because it's a similar idea. So I could have standard being defined as something that sits alongside these prototype definitions. Yeah, maybe I'll do that actually. I see something I'm doing wrong here anyway is, or am I doing it wrong? So I'm trying to access string from standard. Oh, and at this point, I'm trying to perform a get, but I don't know. So this so far is just defined as a hash map from from strings to some kind of value. Whereas what I should be doing is, let's see. Yeah, maybe I will just kind of do it the right way, but I probably don't actually have to add a new parameter as such, just change the type of the existing parameter. So if I leave the definition of standard as is, and I introduce a new, is hash map probably the best approach here. So basically, once I'm in here, it would be nice to be able to match in. So based on the type of, or the variant that this value is, automatically get the associated field from a hash map or something like that. But that wouldn't really be possible. Like what I could do. Though I could still define a function just to get the immutable prototype object associated with a variable. It'll basically erase, well, not erase, it'll ignore the value within the variable, but use its type to actually get the functions or values associated with that type. So let me jump down here and just sketch out what that might look like. So so if I had prototype for, and it took value, yeah, and maybe I'll have a new type around this as well. And then in here we do something like match v, and then it'll basically ignore the values of all these, but then just return the exports, excuse me, associated with them in this kind of prototype definition, which I haven't defined yet. But basically, if I had yeah, a new struct, maybe prototypes, and that would be an enum. No, sorry, not an enum. How do you just define? Oh yeah, you just do struct. So we could have null, so values on a null. So I don't think I'm going to want to allow that. It does complicate things because now I'll have an error case. So again, this is just kind of sketching out an idea first. So we have Boolean, and these will all be basically yeah, hash maps, strings to they'll all be the same as that. Do I want it to be a reference? That would probably be fine, because it'll basically be, yeah, an immutable thing used by all of the code base. So will objects have a prototype? Yes. So in fact, that's the whole reason why we're introducing an alternative syntax to kind of distinguish between accessing fields of an object using dot notation versus accessing properties of its prototype using the arrow notation. So so we'll have func might have so a prototype associated as well, and it'll be the same for both built-in functions and func. Or I suppose that'll be something I'll need to figure out. Yeah. Commands, and yeah, that'll be that should be all right for now. I'll just be doing strings. No, I'll keep all of them like that, and this will basically return. Oops, where did I go? Here we are. I should probably give that some kind of type. It's used quite a lot. And what would that be? Good name for that. That's the same as what's used up here as well. I think object probably wouldn't be a great name for that. And here I am using it anyway. But yeah, I suppose I can just call it object for now, and then maybe clean it up if I think of a better name. And so that'll be so if I implement prototypes, I can't remember the syntax for Rust implement generic type. So I need a oh, that's interesting. It highlights all the occurrences. But so I'll put a type there, and how do I do lifetimes? Just like that, I think. And will I have to probably put it like that? Yeah, there we go. And let's see, prototype for self. Yeah, I think a lot of this just highlights how, well, I was going to say Rust, yeah, I'm with Rust, but how, yeah, just highlights that it's not quite my daily programming language. So self objects. And for these, yeah, for the moment, I'll just have them both pointing to the same thing. Okay, and so with that kind of setup, what that would mean for up here is let variable is equal to that, and then I would do something like prototype for variable. So that would then give me an object if it was successful. So let me think if so that'll be something like a match, and if it's okay, then I can just retrieve it. If it's problem, then I'll return a new error. return the error as is for the moment. And and then once I have the object, I will call it so this is a prop access. Yeah, so this isn't always going to be a call actually. So this makes things a little bit trickier. So I had the assumption that this was going to be a prototype call, but it's actually just a call on a property, but we don't actually know that that's going to be a call at this point in time. It could just be, kind of retrieving the function to store it somewhere else. That's probably all right though, because I have this mechanism for this. So with the prototype function anyway, or running a function defined in a prototype, it's always going to be called on something, and the something in question is going to be referred to as this. So that shouldn't be a huge problem, hopefully, although, come to think of it, I have a feeling I specifically overlooked the handling for this in built-in functions. But anyway, I suppose I'll handle each of those one issue at a time. The first thing to probably focus on is, yeah, it was kind of accidental, but this could kind of work out in the sense of the variable that that will be passed as this to the function. We have a mechanism for that basically, and by creating a new valref with source, and the source in this case is going to be the variable that we got here, and the valref, like the value that we'll have retrieved, will be the value on the right hand side of the property access. So yeah, it was a bit of luck, I feel, at the moment, but that could work out all right. So we get the prototype for that variable, and essentially what we'll do at this point is return the new object that got retrieved. So the variable in this case, and the object that we associate with it. Well, first of all, we actually have to get the field referred to by name out of the object. So, and then that'll be the actual value, and then the object that goes down there as the source is going to be variable. So in this case, we have value is going to be match, and it's going to be a lookup on object. It's going to look up name, and fact, I can reuse that. And maybe instead of object, I'll call that proto props. And that'll be proto val. And I can actually just put that into that space. Don't think I actually need a return there. And what did I have before? Variable instead of object. All right, so that's again, this is sketching out. I don't actually have the setup for this done just yet. Because that's defined on that. Okay, so it's somewhat coming together. Kind of things are, it's not necessarily exactly how I kind of planned it as such, but the logic behind it is making sense to me so far anyway. And so this is based on if it's a prototype lookup or not. Yeah, so that's all right, I think. So yeah, actually not too many errors so far. So what I might do is, yeah, I'll compile this again to see where any current issues are still. So variable clone expected an arc but found a value. That is because we've unwrapped the variable. 996, what's going on down here? I can't find the value object. Is that because I changed object to expression? And I'll just double check the git diff. To make sure that I did. No, that doesn't seem to have, that seemed to be expr all along. So where did that change occur? So that used to be called, so what's now called v used to be called object. So, ooh, yeah, very hairy, but that should let it compile. And yeah, so we're down to 5 errors. Most obvious one is prototypes isn't defined. We'll have to resolve that at some point. So expected that. If I just for the moment call that v prime and call that v. Now, how to distinguish all these v's, I really need to revise those because those are getting incredibly confusing already. 969. Yeah, so that's the prototypes variable 1597. What's going on down here? How do I deal with lifetimes? Oh no, sorry. That is just defining, saying the type that it's not working on. Expected a oh yeah. Can't use an identifier as a function name. Maybe for value. Now I don't love the naming here because it's saying, you know, prototypes for value, whereas it's actually returning a prototype for value, but then prototypes kind of encapsulates the idea that this contains or defines all the prototypes. So maybe prototype 4 actually in the end. Probably makes more sense. And we're down to this error. So yeah, so we've gotten to the point where I should try and define that kind of prototype object. So first of all, I'll make that public type. And oh, hello, man of bad feels. I think you've been on the stream before. Well, welcome back if you have, and welcome if you haven't. Thanks for commenting in. So yeah, so first of all, I need to create this prototypes instance with all of these. These will all just be empty to start off with, more or less. Maybe is a new, and maybe I'll make that type public as well. Oh yeah, the 3 dress code stuff. Yeah. Yeah, apologies for having to rush that. I was editing that video recently and realized I really didn't go into much detail, but it is something that I would like to, as a follow-on from this series, maybe go into. Yeah, maybe if people are interested, go into a bit more depth into the kind of more lower level stuff. Again, if there is interest, I'm not sure how how popular that would be, but so we've bools here to start with, and that would be a mapping from. Oh no, it'll just be an object on its own, which is just a hash map to valref with sources. Oh, perfect. Glad to hear it. So I'll put in new. Does that work? 70. Prototypes. And oh, thanks for the question. So it's I suppose it's its own programming language. It wouldn't really be a transpiler because a transpiler would like is technically a compiler as well anyway. It's just that the target language is generally a more high level language. So I suppose with a transpiler, you're compiling one programming language into another, whereas what I'm doing here is actually an interpreter, which is evaluating the language itself. So, um, with typical compilers that we're familiar with, the output language is generally assembly language, and gets compiled so that you get an executable at the end of it, and then you can kind of run the executable, and that's the runtime. Whereas what I'm doing here is the actual runtime directly. It's probably yeah, probably would be one of the kind of simplest ways to do a programming language. I would to develop a programming language, I would say, and because you don't have to handle all those kind of intermediate representations or like decide, okay, how do I make this run in a different programming language, for example. But JavaScript in particular would be a typical language where you'd see a lot of transpilers. Um, so, for example, TypeScript is, I believe, transpiled into JavaScript then. But yeah, definitely not as much work on the back end with an interpreter, depending on what you're doing it in, and how you're defining the rules. But yeah, typically, um, bit more lightweight on the implementation, especially for getting started with these things. Yeah. But yeah, I'm feeling quite slow with the with the update take today in terms of getting Rust flowing. Um, expected reference found a bool. Not quite sure where the bool is coming from, but so if I do, oh my god, there we go. Maybe I have to do it like that, is it? And so 71, yeah, needs to be a reference instead. And then I just need to, oh yeah, make all of those public and also initialize them. So maybe 8 of these. In fact, I really shouldn't even be implementing these until I need them realistically, but because yeah, I don't have a justification for that, but I'll just leave them as is for the time being. So yeah, now I've got my prototypes defined, and I've standard defined. So my standard, maybe I could call those libs instead, or imports. Maybe standard is fine. And then if I rename, so I'll probably be grouping standard and prototypes. So it'll probably be a good place to create a new structure, perhaps called context, maybe. No. Built-ins, maybe. Yeah, we'll just go with built-ins for now. Don't really have the headspace for thinking about probably good names today. Oh, good names. That reminds me, I have to rename all those V's from earlier as well. But yeah, so for built-ins, it'll consist of prototypes, and standard, which will be an object. And so all these definitions for ST or for standard, I'll probably want to replace with built-ins. At least we'll try this for the moment anyway. Actually, I should update all of those to references too. So here we go. Oops, and went too far. So I'll have a new built-ins, and that will consist of standard and prototypes. And now the rest of the standards will probably have to be updated to that for the most part, except for some of them. Must have missed one parameter. Oops, I wasn't paying attention there. Oh yeah, those are all fine. There probably was only really one actual get to standard around the place anyway. But probably better to to check them out, even though compiler probably would have alerted me if I was doing anything very silly. So how are we now? 41 expected a hash map but found built-ins. So, oh yes, so that's because of that one that I missed. Yeah. So let's try that. Not found in scope. Yeah, it wouldn't be. Oh yes. Oh, those need lifetime specifiers. I could probably just yeah, because those don't all need to be references realistically. I can just define those directly in the object and not hide them behind references, so that'll be all right. Yeah, don't need to borrow anymore for all those. There we go. And so let's see. Yeah, at this point, I can probably just use my built-ins that I've passed through. Prototype found a reference to a variable. Yeah, that's fine. And move occurs. Okay, yeah, that's a good point. So maybe those should be so that's still a valref with source. So I suppose I have a couple of options here. Like realistically, I want to return a reference to this object, kind of a read-only reference. And I could do that with the typical kind of is it arcmutex? I wonder, would it make any sense to try it this way? So that, yeah, so realistically I need to put the sign on those directly. Okay, no, so that yeah, that isn't really a runner because the lifetime of the returned object would need to be you know, that's an object from prototypes. What I'll probably just do for the short term is do a clone, and in future I probably will do an arcmutex to pass around the reference, possibly using an actual value. So try it like that, and then 969, and I'll look at the names of the v variables again in just a sec, but yeah, so I need to pass in, oh, I undid that reference. Okay, so that's working at least. In the sense that it's compiling. So I suppose there's a couple of things to do here. First of all, I need to actually, I'm not sure if strip prefix is actually implemented just yet, but there's a couple of things I need to do. First is actually handle this variable. I don't think it's actually making its way to these built-in functions yet. I don't think they get captured fully. So in order to actually be able to access the variable that a prototype function is being called on, then I need to handle that. The other thing I want to do is just, I know this is a problem all throughout this code base, but here I think it's particularly tricky. So I'm just going to take a look at the names of variables in this section just a bit more. So we have match eval expression. So I evaluate the left-hand side basically. So this can be, it used to be the case that this was meant to be an object, but because prototype access can be performed on any type of variable, that could contain anything. So for the moment, I'll call that value. And that will be like that. So then the next piece of the puzzle is we actually, do we do anything with variable at this point? We don't actually, so I could just put that. It's a bit much to have it all on one line, but it's not actually being used anywhere. And I really don't have a better name to give it, so let's try it like that. So we approach props, and then we have, yeah, in there we can just, well, that'll be proto-prop. Or I suppose that's actually proto-prop. prop val maybe. Then down here we have props as well. Yeah, I might do the same thing in the short term there. Like, yeah, it's all right. It's definitely not ideal, but it's a little better than it once was. So that's the names tidied up some little bit. So first of all, let's take a look. Property name not found. Oh, I deleted something there. I didn't put it back in. So what I'll do is I'm going to define something for here. So this is an object of values. Expect a hash map found in arc reference. So I can actually just define that directly, I believe. So I have so that'll be the actual function definition. So where is it defined? Strip prefix. Also, I actually have a rudimentary implementation of that for the moment. I'll need to put that into a, not an object, but a value function. I wonder, can I oh, actually, some of these will be probably defined as prototype functions as well. In fact, global bindings, will that still be present in future? Not sure. So anyway, for the moment, I'll have strip prefix here. And index out of bounds, yeah, that is to be expected because, at least I think it's to be expected, because I'm only passing in. So when I'm working with a strip prefix, there's only one actual parameter, and I need to have some mechanism for accessing the 0th element, or the this variable. That's the piece that's missing here, and is the reason for that panic. So what's my approach here? So I'll have to take a look at where call is defined, and I'm sure call is being handled differently for built-in functions and for regular functions. And yeah, so for regular functions, I'm actually pushing a new variable onto into the environment called this, and that's fine because that's being evaluated by kind of user code, which has access to the current scope, and this is being added to the current scope. However, with built-in functions, that mechanism isn't there. Instead, we just pass the arguments as an array to a function defined in Rust. So one maybe straightforward, hopefully straightforward approach to that could be to update the definition of built-in functions so that they just take an optional this parameter. So let's take a look at what that might look like. So if I had a built-in function, it could also take an option which is a valref with source. Though in this case, it would actually be the source variable. How is valref with source defined? So a source is another valref with source, so that's all right. So that's an optional this. And then when I call a built-in function, oh yeah, so this is split into two steps. So I can then call a built-in function with so how is this handled down here? So it's handled as this. It's carried with the environment in this case. I'll do I'll do something similar above. In fact, I can just call hopefully handle it like that. And there we go. So yeah, we have source there. And so then when we get down here, we can go fargs this as well. And now I'll have to rewrite all my functions, all my built-in functions to handle that as well. Well, this, but yeah, this function takes one argument, but two are supplied. I'll have to jump to the definition here. So this will have to also be updated to option valref with source. And 1228 found an option. No, expected an option, but found an arc. And up here, expected an arc, but found a reference. So so first of all, I need to update that so that it is an option as well. And let's see, we'll try that. So expect an option there, but found a reference because this is a reference. So in that case, we have source, which is a reference to an option. What's my best way of handling that? Because it doesn't really matter that it's a reference realistically, but yeah, again, adding in a bit of hairiness just to break through the wall, and hopefully it'll get things working. So let this is equal to matching source. I'll probably have to dereference that, I'm not sure. But if it's some v, then I'll clone the v. I'm basically turning. There's probably a better way of doing this as well with all the built-ins around optionals in Rust, but essentially what I'm doing is I'm turning the option I get from here into an option that I own locally. So let's try that. Incorrect number of function parameters. To which, yeah, that looks like what I would now be expecting, because the next piece of the puzzle here is to update all of these to take option valref with source. And this isn't used for most of them, but it is for this this newest function. So let's try that. And oh yeah, that isn't used for most of those. So prefix it with an underscore. All right, and so I'm still getting a panic, but that's because I'm still referencing this v0, whereas I really need to be referencing v0 in here, and I need to reference this here, and I'll just unwrap it for now. And I also need to have it to handle unwrap on none this. So let's try that. Cool, and there we go. Fine. That was yeah, that was a bit arduous. Now there was a bit of moving things around needed for that. As usual, I've made the code a lot messier and not given time to actually cleaning the code again. But that's that. At least in theory, implemented. So basically, the initial implementation of what am I talking about? Kind of immutable type prototypes. And once I've committed that, I'll take a look at I suppose just some more kind of information surrounding that. So that's the implementation of this, yeah. Okay, and that's a commit. Oh, I added a no commit change somewhere there, did I? Oh, that's yeah, I'll just remove that for the time being. Although I'll add it back in and I will commit it just with a no verify. And that is add support for prototypes, for value prototypes. All right, and push it before I do anything else. And so, yeah, so that's at least in theory working now. So let's take a look at how that works. So yeah, basically just kind of strips the prefix here, and if I decided to strip it again, because it's kind of a somewhat idempotent, it'll just kind of leave it as it is in the second call. So that's pretty nice. So that that basically gets us past line 2 of the get Docker script. But this is that functionality is something that I expect I'll be using a lot of in the conversion of this script. So let's see. Yeah, it's an hour and 20 minutes into this stream, so there's a bit of time left, so I can kind of move on and check out maybe a few other statements in this. So here we have the channel to install from. It can be one of these 4 values. This script doesn't actually kind of exit, or it doesn't seem to at least validate the value right here anyway. Maybe it validates it later, and that'll be a bit strange, but maybe. So yeah, I'll just copy paste that for the moment. I'll be using basically the same kind of mechanism as above, where oh, what's happening to okay, internet connection went a bit hairy there, but so we have a default channel value, and that's called channel, and if it doesn't have a value, then it's set to stable. So that's channel sorted. Default download URL, kind of similar here, so it gets converted to just download URL. And I forgot to update that there. And that gets converted to, or set to that. And prototype call, don't actually need that, as it turns out, which is quite nice. Implemented strip prefix and implemented prototype namespace for strings. That was all right. Default, so that'll be repo file. And let's copy that. And there's a good amount of duplication here. So maybe this is kind of a good opportunity to maybe show off some of the benefits. Although it'd be easy for them to for this shell script to have something to cut down on the duplication here as well. So pass in the name of an environment variable, and then you can use $$ to get that variable from the environment, assuming that's implemented in shell. Although that actually is kind of a tricky one, where you take where you can take the name of an environment variable and then evaluate it and set it to something else. It's not always the clearest. And so what might that look like in something like this? So maybe, so OK is already defined in this scope. So that does highlight maybe a bit of trickiness in this language in that. So this is an area where in Go, if you introduce a new variable paired with a non-existing variable, then it declares both, but that does have a bit of trickiness because it can shadow the original. I do need to address that and figure out, because this isn't exactly ergonomic, but this will at least get the thing compiling for the moment. And I'll go ahead and print version. Oh, OK was already defined there as well. So I've got 4 OKs. So I'll print version. I'll print channel. I'll print download URL, and I'll print repo file. So let's check those out. Yeah, so most of these are the defaults. So let's see. How was I passing environment variables in before? Actually, was I modifying the Docker file? No, probably not. Did I modify the dev loop? I did. Yeah, so I had version equals that, and we say default download URL is equal to https download to.docker.com. And we'll start that up again so that we have the new environment, and we now have download to. So when we don't have a value, we take the default. If we do have a value, then we use that instead. So we know what values we're expecting. So now maybe I'll try and do a function to just abstract some of this. So maybe I'll call that env_or. It'll take an environment variable name, and yeah, it'll basically do the same as this. So kind of borrowing heavily from Go as usual here, but the idea being that if when we have a default so let's try that first. We'll try to compile it. So the idea being that we first look up the environment variable with the given name in the process environment. If it's there, we return it. If it's not, then we return the default value. So unrecognized token env_or. So what's going wrong here? Trying to define a function. Do I have to define it with $? Probably at the moment. I actually haven't defined a function since I introduced this kind of dollar notation for identifiers. Yeah, and so that was the issue. So yeah, so that's the way that is. So now let me try and update these. So I'll put the old versions down here, and I'll try using my new function version. So I'll go env_or, and it'll be version. The default will be empty string, and I can actually call strip prefix on it directly like that. and I'll get rid of that. End of or isn't defined. That's correct. Correct. So I got a bit too eager, clearly. And version isn't defined. Yes, so I haven't actually defined that yet. And yeah, so it's now rendering the same as it did before. And now one thing I might do as well is just so I'm not doing the typical scripting thing of defining all these kind of functions in line with the rest of the functionality. I think the Docker script does this at some point as well, but I'm going to define a main section and put all of this into main, and then at the end, after all the functions that main relies on have been defined, call main. So that just maybe a little bit tidier. And again, main has to be defined with $. Yeah, all right, so then channel will be more or less the same. And except we have a stable here. Download URL is going to be that. And repo file is going to replace that. And it can be docker ce.repo. And I could potentially even shorten this further by, well, no, when there are only that many lines, like I could potentially put in a for loop or something, but really is kind of not getting as much of a return on investment there by that point. But yeah, so we've got the same output now, but kind of really cut down on, it really isn't of much consequence. Like we've trimmed these lines a little bit, hopefully made them a little clearer. But again, that's very subjective. So yeah, so next section, I should probably look ahead before I start these streams just to make sure that I'm not jumping into a really challenging section. But what's going on here? So it's basically, yeah, it's running through all the arguments. So it defines a variable initially, defines a mirror, defines whether it's a dry run or not. And okay, so it can take two arguments, checks all the arguments, and if it's got anything it doesn't recognize, then it raises an error. And it shifts on. I'm not quite sure what that does. So if the number of arguments that are left, oh, that's kind of so it's kind of popping arguments off the stack. So it's basically saying while there are arguments left, keep iterating. And this is kind of special handling, it looks like, to account for the fact that once you reach the end of the list, Shell will probably raise an error if you try to pop an extra one. Interesting. But yeah, let's see what that might look like in this language. So I'll get rid of those. Whoops. I'll have to turn off automatic indentation and smart indentation. There we go. And whoops. So let's see. Might put it in its own function. Again, that would probably be a little trickier here because getting the environment out of a function in shell is a little trickier, but because of the structuring of this language, that's a little more feasible for us. So we can define parse args, could possibly define kind of really not sure what's going wrong with the internet today, but yeah. Okay, that's I don't know. Bluetooth seems to be interfering with my connection earlier. I'm not sure what's going on now though. But yeah, I'll just keep going. So I parse args. Maybe someone close by is I don't know, watching Netflix or something. Very possible. So going parse args. I'm just gonna keep an eye on the internet speed. Um, so it won't take anything there. So so this is going to be using stuff that I haven't exactly implemented just yet. But we'll go for arg in, and we'll be using something defined in pros, which will be args, and then so I'll basically have a local arguments object, which I'll return at the end. And yeah, so it'll basically be, I don't have any kind of matches or switch statements in this language so far, but I can just do it the old-fashioned way for the moment. So it'll be if arg is equal to mirror, and maybe I have to kind of define better semantics for or kind of rules for exactly when does it make sense to put commas around or put quotes around these things and when not. But for the moment, so it'd be args mirror is equal to true, args run. Okay, so that actually will shift the so I won't be able to do something as simple as just doing for arg in process args. It'll have to be something more like let I equal 0, while I is less than process args length I plus plus. Not sure if it has plus plus actually. I think I did the Python thing and just have plus equals. So that'll be I plus equals 1 as well. So args mirror will be so we'll have arg is equal to process args. No, it'll be process args I. And nice thing about this as well is that it won't be destructive of the actual args kind of variable as it is in, well, that's not quite destructive, but you can only do this kind of shifting once really, as far as I'm aware. Well, maybe you can do an unshift, I'm actually not sure. I certainly haven't seen that in practice, but we'll basically go process args I plus 1 here. Now, this will throw an exception or panic or what have you if that variable isn't defined. So for this language, that's fine. The expectation is if you don't provide that argument, then well, it has to be defined, and if you don't, that's an unhandled case. Maybe sometime there can be a library to handle this in a more elegant way, but in terms of kind of getting something, kind of doing the right thing quickly, this is the approach that will be taken here. And then the last thing is to actually so illegal option that. And then what does it do if if it doesn't start with hyphen hyphen? Oh, it'll actually keep the rest of the arguments. So it'll no, it keeps looping until so so it might just ignore positional arguments. I'm not sure. So if the argument is mirror or dry run, then you do those things. But then if it starts with hyphen hyphen, then you say that's an illegal option. But if it doesn't start with hyphen hyphen, then it just gets ignored, it seems. I'm not sure. But yeah, just to keep parity with it, I suppose I'll go if arg starts with hyphen hyphen, and I'll need to introduce a new mechanism, maybe bang. I'm not sure. Maybe it'll be nicer to actually just yeah, I suppose I'll just handle it like this for the moment. Legal option, and that'll be like that. So there are a couple of things that are not yet implemented here. So first of all, we don't, so process args doesn't exist. What else? Starts with isn't defined. Thought there were other bits, but maybe that's it. Oh, panic. I haven't defined panic yet either. So yeah, maybe I'll go ahead and try. Oh, and len actually, that's a big one too. So three of those aren't handled. So oops. So property name not found. That's not very very helpful error message. That'll be something to clean up here. So val, maybe I could I don't know, maybe print the property name that wasn't found. And that's on yeah, I'm not sure where that's actually originating even. But anyway, property name not found. And we'll put the name in there. Oh, I seem to have another place where I'm doing the same. And we have, yeah, property name args not found. Okay, that makes sense. That would be the first one we come across. So that should be a matter of adding that to main and popping that alongside env. So that would be actually the formatting of that needs to be updated. And so the arguments in this case will have to be, yeah, I'll have to define that further, but it'll essentially be the arguments after the script name that go into main. Since this is a work in progress branch, I'd probably just hard code these, you know, some example values here for the moment. Yeah, I think I will. Just to demonstrate some of the ideas. And that's a string s, and we'll say dry run is true, and we'll say mirror is, you know, ABC for now, and then we'll define it again and say, oh, actually it's 1, 2, 3. And we'll try triggering the that illegal flag as well. So I'll have to convert all of those to strings. Yeah, so we now have that. So now that args is defined, we find out that length isn't defined as a property access. So it's defined in the global scope, but I actually want to define this as a kind of a prototype function for the things that support it. So that's actually already defined for list in the global scope. So what I want to define here is list len. Not actually sure what to do here if it doesn't match, if this doesn't match a list, because the expectation by this point is that it'll already have that could be something to improve actually, is that by this point for some of these functions we already know what the inside value is. It'd be nice to be able to keep that information, but that is, you know, that's all right for now. So we'll go this unwrap. So this will be a dev error at this point. Called on non-list. So panic would probably be more appropriate here, because there's nothing that the developer will be able to do to resolve this. This will actually be, you know, an issue with the evaluator itself. Maybe that's a to do. Oops. So we list len. We can define that in the section of ints. No, of lists. So we'll try that. These isn't used there. And so then back to Docker get. The next one is that, and you know, I've really been putting off putting kind of error lines into this, but yeah, that'll, again, lots of stuff to be done here. So arg isn't defined. Yeah, so I just need to put in a let there. Property name starts with isn't found. Yeah, so that's just a matter of defining that too. So we'll have s and prefix, and return s starts with prefix. I believe that's so that just has to be added to the definition. And finally panic, so that'll be defined globally at the moment. all it'll actually do is basically return a new error. And so it'll, what will it do? It'll actually, no, not like that. It'll match the first argument, which should be a string. So that'll be string s, and it'll return error s. I'll probably have to clone that. So panic at the moment will only be, it'll only be possible to call it on strings. You know, this probably won't be this is very unlikely to be a final mechanism on this, even though the aim of this language isn't to have very rigorous kind of error handling semantics, because the intention is nearly, if you need that much flexibility, you should probably be moving to a kind of a more, not robust programming language, but I suppose your script is probably getting to the point where the Laurel programming language is probably a little too lightweight to handle that stuff. But you know, that's again something I have to figure out a bit more in time. So expected string there, found that, so I'll have to do a toss string. Define panic there. And okay, so we're compiling, and we've got the illegal option that we expected. So we go down here and remove Miro. And actually, we're not actually printing out the args that we got back, but let's see, print args. Can only call functions, yes. Because that was assuming that print was a command line program. I was trying to call directly on that. But anyway, we've dry run is true and mirror is 1, 2, 3 like we'd expect. And so we basically have the same functionality here. Probably more code, but especially compared to the likes of this, you know, I would probably consider this to be at least not necessarily more readable, but I suppose more expected, or less surprising to people coming along to it. I suppose if you're familiar with kind of a number of other mainstream languages like Java, JavaScript, Go, Rust, any of these kind of things, then this is probably going to be a lot more familiar. And it's also kind of, you know, encapsulated, separated from the main function. So, you know, you don't even have to really look at what's going on in parse args. You can just see, okay, what's the result? So yeah, so that's pretty nice. That's another kind of nice chunk of the script handled. So with that done, what I might do is, yeah, commit what I have so far. And that's mostly kind of adding new built-in functions or prototype functions. I've added some new no commits messages, so so I'll ignore those. And so this will be convert more of get docker.com script. argument processing. All right, so that kind of brings us up to time more or less, but I'm enjoying converting bits of this, so we're not too far into it. But let's see, what are the next two bits? Changes the download URL based on the mirror. Yeah, I think I might convert that, and creates two new functions based off of external commands. So I'm going to try, yeah, I won't give it too much longer, but I'll try and convert this, and depending on how those go, I'll maybe look at version GTE, although that uses another function down here. So maybe yeah, I'll try the initials parts of these. So first of all, let's look at this. So if mirror is that, so that could probably be put into its own little function as well. And what was it? If mirror is equal to that value, then we return that. And else if that, return that. And so now I could either decide if I return null here or if I provide default. And maybe it'd be easier to provide a default. So return default there, and download URL from mirror. Though that kind of gives the wrong impression, or that name kind of makes it think that you're actually downloading a URL. So yeah, I do need to rename that, but for the moment, we'll do this, and we'll go args mirror. Now this will fail if mirror is empty, and actually that's something that was done earlier, is that was defined to be empty, and dry run was actually defined to be, I'm actually not sure what that does. So shell interpolation. No. So parameter and offset. Okay, so it could take that value from the environment as well. So if it's already defined in the environment, then you take its value. Otherwise, for some reason that just isn't processing for me today. I'm not sure what's going on, but yeah, I'm not getting that. So yeah, I'll add that as a to-do item hopefully as well. But for the moment anyway, the one thing I do know is that mirror is empty string. So then we have args mirror, and we use the existing download URL and copy that to that. Yeah, that is something I would like to rename eventually, but for the moment, I think, yeah, we're probably all right. So there was an unexpected end of file for some reason. Oh wait, that was because I had that comment in there, and the language just does not support comments right now properly. It only supports having comments at the end of the file because it consumes everything that occurs after the comment. So you can't have single line comments at the moment. I really have to modify the what's it called, the lexer. So so there was 1, 2, 3. So maybe if I change that to, what was it called, Alion. Let's try that. And yeah, it converts it successfully. So so that's that. And next we want to implement command exists. So it just checks. So what does that do? So if I go command v docker, and it gives, okay, oh, is that a built-in or something? No, the built-ins usually have man pages as well. Seems kind of similar to which, but maybe it's POSIX compliant or something. Not actually familiar with that, but let's try that. And so function command exists. And this is actually the first, even though this language that I'm writing is meant to be optimized for calling programs, this is actually the first time I've actually needed to call a program in this script so far. So I won't actually need to redirect it to dev null because the output is automatically captured. This will redirect the standard out and standard error to dev null. Those are both captured, so I don't need to do that, so I can get rid of those. This $args is basically just the parameter list. Now, one thing I don't support is variable argument lists. You know, I could take it as, if I wanted to pass the list in here, I could take it as a list. But yeah, but basically, I can, that should be, So the idea there is that that will, what does that return then if it doesn't exist? So it returns 1 as you'd expect, I assume, which operates more or less the same way. Now the only thing about that is this script starts with a set E, so it exits on error. So if that returns, non-zero, and the default behavior of the Laurel language that I'm writing will be the same, that unless you specify otherwise, your the script, now it's not implemented yet, but the script will fail if the program returns non-zero. But I'm not sure how it's getting around that here, because you'd have to basically turn that off for this. There are a couple of to-dos around this for me as well, because first of all, this doesn't actually fail if the command returns non-zero, and it's something that I do want it to do. The other thing I'll need is when I do have it failing, that I'm able to catch the error and basically turn it into a Boolean. So it basically will say, did this command fail? If it did, return false. If it didn't, return true, kind of a thing. But basically that will run the command with the, well, no, sorry. That will run the command with the given arguments, and I'll just go return there for the moment. That has to be refined, but that can be done at another point in time. And so then the last function that I'm going to work on today is version GTE, and this does it in 2 phases. First, it checks if the version environment variable is set, so it's using that as a global, and it's saying if it's not set, so there isn't a version, so it's 0, return true. I'm actually not sure what return does is it the same as exit? I assume so. So it probably makes the function, so bash or shell functions generally operate similar to processes. So I assume return 0 is, return a 0 exit code. So in my case, it would be more like, so version GTE, so greater than or equal to, and I'll actually take a version string here, so that when it gets called, it'll actually take the global variable as a local variable. So first of all, it wants to check is that even set. So for the moment, I can say if it's equal to 0 or if it's empty, then I say that it is GTE, so return true. Otherwise, calendar version compare. And what's it comparing? So checks if the version specified in the environment variable is at least the given calendar version. So it returns success if the version is unset. So yeah, we return true in that case. Whoops. Oh yeah, and it takes another variable. So so if I call that A and B, so yeah, that'll be, yeah, I suppose just to keep it, yeah, what do I do here? Because I've, you know, and I've actually modified the version at this point. So yeah, not really sure what best to do here, but for the moment, I'll do, yeah, calver compare A and B. So version GTE at the moment is just a direct call to calver compare, and calver compare then is return 0 if version A is, so that's actually handy because I'm using A and B as well. So if version A, which I'll be using as the first parameter, is newer or equal than version B. Patch releases and pre-releases are not taken into account. So I will try this. You know, it's yeah. So first of all, it turns on debugging, I believe, so that all of this stuff is actually printed to the terminal as it's evaluated. So yeah, so that's I might just shrink that like that so that I can write it alongside it. So let's see. So we have the year of A, and this is going to do. So it takes the first half of this string of A and B. So in my case, I can actually, well, it depends actually. This does have the flexibility that it's based off of. Now, yeah, this has the flexibility that's based off of the dot rather than actual positions. So if, yeah, if for some reason this handled more than two positions in the year or fewer, then that would be handled correctly. So what I would probably want to do in that case is, let's see, I think I can omit the initial and final positions from a in fact, I don't have string ranges in this just yet, but what I should be able to do is index of dot. Now this isn't implemented and string ranges aren't implemented, so those have to be done before this is functioning, but this is again more of a sketch. So we'll do the same here with year B, and so this checks is, so I'll have to convert mine to an int as well. Now I had some ideas on exactly how I wanted to do some of the parsing in this language, like string parsing and things like that. You know, Python can make it very easy by just, you know, you'd say int, and it gets parsed to an int from a string. For kind of making different things easier, I was thinking of having a collection of, say, you know, library or imports or from ints, things like that, so that, you know, you can be very explicit about the conversions. For the moment, though, I suppose it makes sense to just do it in the basic way. And so I'll go if YYA is less than YYB, So that's return false, return true, and then basically the same for, so that removes, okay, because those could have 0 at the start. So that would be +1, and those will be m's, and so it'll be MMA. So that'll have to be something like strip prefix 0. In fact, do I need to strip the prefix? It depends on how int will operate. If it parses 001 as just as 1, then there won't be a need to strip the prefix here. If I decide to well, no, it wouldn't make much sense to allow, say, 0x or 0 at the start of a string, because like that's valid for number literals, but isn't as typical for actual string parsing. So I shouldn't actually need to strip the prefix there. Again, I can use Rust as a reference here as well and see what they do, but yeah, I think I'll leave it out for now. But I'll need to test it on say 1903. So if I go and I change the version in where was it, dev loop. So we have 1903 there as the version. And then finally, if month A is less than month B, then we return false. Otherwise, we return true. So we return true if month A is greater than or equal to month B. And that is a calendar version comparison done. Let me just think. Another way this could be implemented is, let's see. I could do, so even this is based off the assumption that these are correctly formatted with a single dot in the middle. It doesn't actually check the length or validate that assumption. It basically will just say that if there is an additional dot or any other formatting like that, then it'll basically ignore it. We can actually be a little stricter here and potentially, I don't know, yeah, I suppose just a little stricter here, and do something like a split on dot. And in fact, I forgot to use the lets here, but we could have let year A here and let month A there, and do the same for B. But we still have to apply the integer function to those. Probably a bit much, but let's try that maybe. So we could have that, and then we can get rid of all those. and then our caliber compare gets just a little more precise. So it'll actually reject. Now the error message that gives probably won't be the most descriptive to a user, but at least it won't ignore, you know, invalid invalid input. So yeah, um, there's a bit to actually implement to get this working. So I don't have map implemented. I don't have integer parsing implemented. Splitting. What else? But that's nearly it actually. The older version, I would also need to implement index. I'd also need to implement string ranges. But yeah, those could be some nice things to do in next week's stream. Um, anyway, I'm going to leave it there. Excuse me. Thanks very much to everyone who tuned in. So what actually got done? I suppose the big thing that got done today really was the implementation of prototypes. Um, so this kind of notation where if you do have a variable of any type, then there is, a number of associated functions. Well, at the moment they're just our methods. So there's just a number of associated methods with each type that can be called on them, and it's basically syntactic sugar to like these could be just defined in global functions or there could be specific packages defined for each type. But this, I suppose, just makes the whole mechanism a little cleaner, I guess. So with all of that said and done, yeah, that the rest of the stream then was probably just kind of converting this, continuing on with the conversion of this script in a mini project. So yeah, again, thanks very much to everyone who kind of tuned in and commented on things, and yeah, see everyone next week. Take care.